Greetings to all the viewers. The session is going to cover with the concept called carbazole. Carbazole preferably named as 9H carbazole in accordance with the IUPAC nomenclature. IUPAC stands for International Union for Pure and Applied Chemistry. And the session covered by artificial intelligence, AI-powered session it will be. And it is the tricyclic system, polyannular it might be, and two benzene rings fused with the pyrrole, which is said to be what? Which is said to be carbazole, and here you can denote indole condensed with another benzene is also denoted as this carbazole molecule. And you can observe three-dimensional representation of this carbazole where nitrogen taken as a heteroatom. All the carbon atoms are connected with the hydrogens in accordance to satisfy their tetravalency, right? So this is the way carbazole is considered for the day. Let me introduce carbazole. Carbazole is a heteroaromatic compound with molecular formula C12H9N. 12 carbon atoms are located and 9 hydrogens are linked with these carbon atoms, and one of the nitrogen is also connected with with this hydrogen atom. Here you can clearly observe and there is a naming system. The numbering will be started from the carbon and 1, 2, 3, 4, and let me jump into another benzene ring where 5, 6, 7, 8 in continuation. Always bridgehead carbon atoms given with the least priority. They may not be considered in the numbering system. Rather, you may go with the additional numbering after the completion of this one 1, 2, 3, 4 and the continuation 5, 6, 7, 8. Later, the atoms whichever bridging in between two benzene are regarded as 4A and 4B. Whatever coming in adjacent opposite direction, they are designated as 8A, 9A, and the heteroatom given with 9. This is the exceptional nomenclature. This is somewhat different with respect to all the heterocyclics what we discussed in the previous session, where always numbering will be initiated from the heteroatom itself. It is somewhat exceptional condition you can clearly observe where carbon is accorded with the numbering, and bridged carbon atoms may overlooked, and later finally we will get heteroatom over here. This is the way it consists of two benzene rings fused with the pyrrole moiety. Either of the side nitrogen containing pyrrole ring will be there. It is a part of tricyclic ring system. Electronic properties are mentioned for this compound, important compound, both research and industrial applications, right? So this carbazole molecule is most vital in research and industrial purpose as well. And its a 3D dimension is also provided where benzene ring in conjunction with this 5-member ring system, again benzene ring fused. 3 fused ring systems are connected in a same plane, and here is the nitrogen atom connected with the hydrogen. And you can also observe 3-dimensional representation without any bonds. Here is the molecule of carbazole manifested, right? So carbazole is a aromatic heterocyclic organic compound. It is the tricyclic one consisting two benzene rings and 5-membered ring with the nitrogen heteroatom is included in that. The compound structure based on indole. Here is the shaded one. Shaded ring is provided. Green color shade you can locate, which is the indole nucleus. And here another fused one is said to be benzene one, right? So this is the way indole fused benzene is also the kind of carbazole it will be, and that 5-member ring system at the position of 2 and 3. Indole will be connected with this, right? So this is the way indole fused benzene, or else 2 benzene fused with pyrrole, or else polynuclear aromatic system with nitrogen heteroatom. So many descriptions you can provide for this carbazole molecule, right? Carbazole can be extracted from the starting material, which is coal tar, in accordance with the eminent scientists Carl Grabe and Carl Glaser. First isolated this compound in the year 1872 from the component of coal tar. Coal tar, everybody aware about that. Coal tar is the product which extracted whenever petroleum product is going to be extracted. In that, hydrocarbon mixture will be there. Higher, heavier molecular weight hydrocarbons are the composition of this coal tar, and that is also the source in order to extract. The first extraction was carried initially in the year 1872, and this will be the composition. Let me see where can you locate this carbazole. Carbazole can extracted either from bacteria or else even fungi, and from the plant materials as well. This kind of carbazole molecule will be extracted so that we can designate the molecule as a biomolecule, being it is extracted from the bacteria, fungi, and sponges. What natural biological organisms are available in order to extract this carbazole. If you observe, carbazomycin D is available from actinobacteria. This actinobacteria is the source in order to extract this carbazomycin D, whose structural skeleton is provided where carbazole is a core moiety. And another carbazole in addition to that phenol ring fused one is also there. Prekinamycin. It is a kind designated as a prekinamycin. Actinobacteria. Again, it is extracted from the actinobacteria. And let me introduce another kind of carbazole in conjunction with the quinoline moiety. Calothrixin. Calothrixin B, the name is provided, and cyanobacteria is the source in order to extract this chemical compound, right? And we have another bacteria here, that is cyanobacteria. Cyanobacteria is the source in order to extract this halazole. Halazole is the compound where you can locate carbazole in addition to the benzene, and where methoxy and methyl functionalities are located on this carbazole skeleton. And let me go with another specified skeleton you can clearly observe, which is a carbazole one. And here is the pyrrole ring system. And here is the indole ring system taken part of this carbazole. Dihydroxy staurosporinone. Dihydroxystaurosporinone is the kind of compound you can clearly observe. Myxomycetes. Myxomycetes is the kind of organism from which you are able to extract this effective carbazole compound. Let me introduce another microorganism, fungi. So from this fungi also it is possible to extract the carbazole, which is extended with the saturated rings of cyclohexane. Two cyclohexane rings got fused with this carbazole one, and that is called tubengensin A. Tubengensin A is the kind of compound which is composed by the carbazole extracted from the microorganism fungi. And granulatamide is having composition of this imidazole and pyrrole ring, which are fused on the carbazole moiety, extracted from tunicates. So tunicates also the kind of microorganism from which the kind of carbazole is extracted. In either very complex molecule extracted from the sponges. Sponges are also the kind of microorganisms you can observe. So which is called a dictyodendrin. Dictyodendrin A is the kind of chemical compound extracted where you can observe the carbazole at its core, and polyannular system it will be. Ellipticin is another compound where carbazole fused with the pyridine you can clearly observe. Plants and Apocynaceae, Loganiaceae kind of plants from which you are able to extract this kind of carbazole. So that biomolecules also having the composition of carbazole, so that carbazole is also the kind of phytochemical and zoochemical as well. So that plant extraction and animal extraction both are possible. Significance of carbazole. Carbazole having multiple potential application, especially in the form of pharmacopoeia, and also material chemistry applications, agrochemistry applications are noticed for this molecule. If you observe, antifungal for carbazole is introduced over here, which also having potential anti-cancer activity as well, where carbazole is having their aldehyde and methoxy at the position of benzene. And another carbazole is there, which is connected with this pyridine, so that amplification of the property, and this pyridine existing in the form of its pyridinium acetate salt. And here is another hydroxyl functionality at another benzene ring, so which is called Celiptium. Celiptium is the trade name of the compound which is clinically approved anti-cancer agent. Already research have been done. After getting research, that also diagnosed for that anti-cancer curative agent, right? So another carbazole related moiety which is existing in the form of quinoid form. One of the benzene ring in benzenoid, another benzene ring in quinoid form. The compound is said to be clasinaquinone. Clasinaquinone is the kind of compound which is effective anti-cancer agent. Malignant tumors are effectively curated by means of this carbazole 1. And calothrixin. Calothrixin A is another compound where quinol in conjunction with this carbazole in the form of quinoid 1. So again, quinoid form of the carbazole was taken, and quinoline inoxide is connected with this one, which is anti-parasitic, anti-cancer as well, right? So parasites will be destroyed by this one, and the cancer get curated by means of this carbazole pharmacophore. Let me introduce another kind of one, very similar with this one. So that is calothrixin A, calothrixin B. Both are similar kind of compounds. Only the difference you can notice is inoxide is absent in case of calothrixin B. Again, it is having same kind of activity just like calothrixin A, like antiparasitic and anti-cancer as well. Let me introduce enalkylated carbazole. That enalkylated carbazole, where another nitrogen is existing in the form of tertiary amine. Pyraxine is the name of this compound, which is again anti-cancer. Most of the compounds whichever mentioned in this slide are the part of that anti-cancer curatives. Now, let me extend the applicability of this carbazole in the field of pharmacopoeia. Then carbazole scaffold is the part of this Celiptium. Celiptium is the kind of drug you can clearly observe where carbazole in conjunction with this pyridinium acetate again. So that is anti-neoplastic. Just now we observed that is anti-cancer curative. And here carvedilol. Carvedilol is a kind of beta blocker. You can observe carbazole is located over here, and a long chain of alkyl is substituted on the benzene ring where ether linkage. Hydroxyl functionality, secondary amine, again ether and benzene with methoxy. This is the extendable chain you can locate upon this carbazole, which is called a carvedilol, which is said to be beta blocker, able to work upon this cardiovascular diseases. Then carprofen. Carprofen is the kind of drug where carbazole with the chloro potential pharmacophore again in terms of structure activity relationship, and another extendable alkyl chain over this benzene ring with the terminal carboxylic acid is having anti-inflammatory property. Let me introduce a kind of simple carbazole with the methoxy and methyl functionalities, which is called Muriafolin. Muriafolin A is the fungicide. Fungal infections, dermatology diseases get better curated by means of this kind of Muriafolin A. Another carbazole derivative will be a methoxy and alcoholic derivative of this carbazole. Quinoline is a kind of anti-proliferative, a kind of immunity defensive system will be developed by the consumption of the drug called a quinoline. Quinoline is an anti-proliferative agent. Clazoline J is an anti-HIV. So here HIV syndrome will be better curated by means of this carbazole, where methoxy and carboxylic acid and again methoxy located upon this carbazole. Another carbazole moiety is there with methyl functionalities and methoxy hydroxyl over the benzene ring, which is a carbazomycin B, which is an antibacterial agent. This is the way carbazole significance will be elaborated in this slide. So many applications we observed in the field of medicine, in the field of disease curative agents. By that, we ended up with that significance. Later, we entered into the segment called synthesis of carbazole, where from the cyclization of diaryl amines. Diaryl amine is the kind of compound taken to be cyclized in the presence of a transition metal acetate. Here, palladium diacetate is taken, dissolving in a glacial acetic acid solvent and heating to the temperature of 110 degrees centigrade so that it will participate in the ring cyclization by the activation of the carbon atoms at the position number 4A and 4B, so that ring cyclization occurs, so that aromatization is accomplished in a carbazole molecule. This is the way ring cyclization giving rise by this diaryl amine starting material in the presence of transition metal acetate palladium acetate catalyst. Let me introduce Boucher-Drechsel cyclization. Boucher-Drechsel cyclization is a classical method. Intramolecular cyclization is possible. Intramolecular dealt with if two different molecules are supposed to be cyclized. Intramolecular is said to be within the molecule if the cyclization is accomplished after the mixing of two molecules. They are participating within the molecule. The cyclization is accomplished, so that we can designate this kind of cyclization as an intramolecular. Being this compound, a single compound is participating in the ring cyclization over here. In order to get intramolecular ring cyclization, the starting materials taken are, one is phenylhydrazine in either cyclohexanone. These two molecules, being it is a ammonia derivative, obviously go with the condensation with the carbonyl compound giving rise to its corresponding derivative, which is said to be hydrazine giving rise to hydrazone derivative, so that cyclohexanone hydrazone derivative will be originated. Later on, let me go for this intermolecular ring cyclization. Within the molecule ring cyclization is accomplished under acidified conditions. Acid catalyst is applied over there, so that deamination followed by ring cyclization giving rise to a saturated one. Saturated being cyclohexane is the kind of saturated, so that here a certain extent, how much? 4-hydro carbazole is originated. This to be removed with the hydrogen, so that oxidizing agent is necessary as a catalyst, so that here lead oxide is applied over the saturated one giving rise to aromatic carbazole as a final product. This is the way Boucher-Drechsel cyclization will be accomplished. Let me introduce another named reaction where Bucherer-Carbazole synthesis is provided over there. The reaction between beta-naphthol and phenylhydrazine, both are supposed to be condensed in such a manner. Beta-naphthol and phenylhydrazine in the presence of sodium bisulfite. This is said to be sodium bisulfite, so that initially condensation between these two, so that condensation giving rise to water as a byproduct. Here is the NH. N-phenyl will be there. Later, they will participate in the ring cyclization, which is again said to be intermolecular ring cyclization, again giving rise to a kind of a carbazole with the benzene as an additional fused ring over there. Benzocarbazole is the name accorded for the final product. This is the way Bucherer-Carbazole synthesis is performed in order to achieve this benzocarbazole as a final product. There is another named reaction called Harving amination process, where I'm taking alpha chloroaniline as one of the starting material and bromobenzene was taken. Palladium tertiary butyl phosphate is a kind of catalyst applied, and base is also included as a catalyst over there, so that it will participate in a kind of condensation. Again, HBr will be removed and this amino will be attached over there, so that there is a bridging nitrogen generated. Later, hydrogen from this adjacent carbon atom and chloro from this carbon atom will be departed, giving rise to ring cyclization. Again, it is the part of intramolecular ring cyclization giving rise to carbazole derivative. If you are taking any alkyl substitutions over the aryl ring, that will taken as the substitutions on the carbazole skeleton. This is the way short Harving amination process will be accomplished. By this, we concluded with the synthetic plethora of the carbazole molecule. Let me enter into the segment called the physical properties of the carbazole. Carbazole, which is accorded with the molecular formula C12H9N, it is the kind of bulkier one when compared to the earlier sessions what we discussed, being it is a triannular system, so that 12 carbons taken part of this one and 9 hydrogens are connected with the carbons and one of the nitrogen as well, and there is one nitrogen heteroatom included over there. Molecular weight of this compound is 167.21 gram per mole, and it looks like a white to pale yellow color crystalline solid. Being it is a high molecular weight substance, obviously existence is solid one, and moreover it is the crystalline substances are having clear crystal lattices, and the bond angles, bond distances are particularly dimensional and regular arrangement you can observe, right? Melts at the temperature of 238 to 245 degrees centigrade temperature, and the solubility, being it is a bulkier one and more carbon content is available for the compound, so that obviously go with the solubility of organic solvents like ethanol, chloroform, and benzene. These are the suitable organic solvents in order to dissolve the compound because of the higher nature of the carbon. Solubility, just now we observed organic solvents are more preferable in order to dissolve the substance of carbazole. Let me discuss about the chemical properties of the carbazole. Chemical properties are manifested over here. Carbazole exhibit a unique chemical properties because of its aromatic heterocyclic ring structure, and a nitrogen taken as a heteroatom in the 5-member ring system, and its reactivity is categorized into electrophilic substitution, oxidation, reduction, reactions involving the nitrogen separately discussed over there. These many probable chemical properties we are going to discuss in a following slides. Reason for the aromaticity. So aromatic carbazole obviously designated as an aromatic substance because of its planarity. Though it is of tricyclic ring system, all the rings are laying on the same plane, being it is a flat molecule, and effective pi orbital overlap is possible across the entire ring system. So this is said to be planar one. Conjugation, you can notice because of the aromaticity, because of the sp2 hybridization, because of that kind of alternative arrangement of the pi bonds, there is the existence of conjugation is possible. All three fused ring systems, two benzene rings and another pyrrole-like ring are in accordance with this conjugation. They are arranged. Nitrogen in the 5-membered ring contributes the lone pair of electrons in order to satisfy the aromatic property, so that conjugation will be continuous within the ring system. Huckel molecular orbital theory is perfectly obeyed by the compound, and in accordance with the Huckel rule, 4n plus 2 is given 10 pi electron system. If we count the pi electrons of this, let me show here. Let me count the pi electrons of this one. 2 plus 2, 4, 6, 8, 10, 12. 12 pi electron system is located over there. 6 plus 6, 12 pi electrons are taken part of that one, and benzene rings are contributing these many pi bonds, and nitrogen also contributing lone pair of electrons into the aromatic ring system. That is the reason why 4n plus 2 pi electrons is equal to how many? 12 plus 2 electrons, total 14 electron system it will be. So that is the reason why it is obeying the Huckel rule, right? Delocalization of pi electrons you can observe. All the electrons are in conjugation, and moreover the lone pair of electrons and the nitrogen taken part of this delocalization, so that it is said to be aromatic in nature. These many reasons beyond the aromaticity of this carbazole molecule, so that we can designate it as a aromatic compound. And it is supposed to be treated with electrophilic reagents in order to perform this electrophilic substitution reactions upon this carbazole one. And more preferable positions are 3rd and 6th positions within this polyannular system. These are accomplished with the high electron density, deposition of high electron density in comparison to the remaining all the carbon atom. That's the reason why more preferable position for the electrophilic substitution will be 3rd and 6th. Let me perform the nitration over this carbazole by adding with the concentrated nitric acid, dissolving in the glacial acetic acid solvent, giving rise to nitro substitution over the position number 3 nitrocarbazole as the expected product. Nitronium ion having a more preferential attachment over the position number 3, being it is having the position 3 carbon is accompanied by the high electron density, so the T3 nitrocarbazole as the final product. And sulfonation is performed by adding with the concentrated sulfuric acid over the carbazole, giving rise to carbazole 3 sulfonic acid. This is the expected product. Halogenation upon the carbazole will be performed with bromine dissolving in acetic acid solvent 3-bromo. Carbazole will be the product over there. Same halogenation is also performed by means of this eco-friendly process where hydrogen peroxide is able to release the one of the oxygen and can be converted into water as the product, and chloroperoxidase. Chloroperoxidase will be originated where chloro is a kind of chloronium ion that able to attach with the that halide, which might be a kind of which might be a kind of reagent extracted from either HX or HOX. HOX denotes what? Hypohalous acid. Hypochlorous acid or hypobromous acid you can denote, where the electrophile may be chloronium ion or bromonium ion to be treated with this carbazole, giving rise to that kind of substitution. Instead of monosubstitution, you can observe at least one to the higher number up to 4. That means mono substitution to tetra substitution, that extent of substitution is possible by means of this chloroperoxidase catalyzed halogenation process. Let me give the glance regarding this electrophilic substitution. Carbazole to be performed with this nitration in the presence of nitrating mixture, giving rise to polynitration over there. Here the substitution at the position number 3 and 5 together nitrated, and sulfonation is accomplished. This is the kind of vigorous condition you can apply. A sulfuric acid releasing the sulfur trioxide that able to substitute in both the positions, giving rise to disulfonic acid derivative of the carbazole. Let me introduce the halogenating agent like bromochloroiodo as well, so that here dihalo carbazole is the expected product. So this is the way a kind of carbazole will participate in the electrophilic substitution. In addition, Friedel-Crafts alkylation is also accomplished by this carbazole whenever alkylating agent can be treated in the presence of Lewis acid, that is iron. Iron taken Na plus 3, Fe plus 3 taken as a catalyst, and the reaction is operated at the room temperature condition, so that alkylation is accomplished either at the position number 3 or position number 6, right? So this is the way, sorry, not either, both the position number 3 and position number 6 as well, right? So that is called alkylation. Alkylation is accomplished in the presence of Lewis acid, and alkylating agent preferentially go to the substitution at the both the positions like 3rd and 6th as well. And let me perform this oxidation reaction upon this carbazole. Oxidizing agent will be a strong potassium permanganate or else chromic acid will be applied over this carbazole that able to convert one of the benzenoid moiety into a quinonoid one, so that carbazole 1,4-quinone will be the expected oxidized product. One of the lobe existing in a benzenoid molecular skeleton, another benzene transformed into a quinonoid form. Benzenoid-quinonoid transformation is possible by this oxidation process. Let me go with the reduction. Reduction can be performed upon the carbazole in the presence of either nickel or iron catalyst, so that able to reduce the extent of reduction will be partial only. We are not supposed to reduce the entire pi bonds existing within the molecule. Rather, only 1,4 positions selectively go for the reduction, so that 1,4-dihydrocarbazole is the expected product by the reduction in the presence of nickel or the iron catalyst. Transition metals taken as a catalyst, and there is a specific reduction like a Birch reduction, resembling with the Birch reduction. Tetrahydro or else dihydrocarbazole is the partially reduced product. Let me go with the complete reduction. Hydrogenation in the presence of transition metal ruthenium. Ruthenium metal is applied over there so that being it is a strong oxidizing agent, entire benzenoid aromaticity will be destroyed and all the skeleton aromatic ring systems will be transformed into saturated, which is said to be carbazolidine. Carbazolidine stands for all the pi bonds removed and giving rise to complete hydrogenation. Ruthenium is the efficient catalyst for this complete hydrogenation process. And let me go for enalkylation. This is the reaction upon the nitrogen, which is said to be in substitution. So as of now, we gone through the carbon related, that means benzene ring and carbon related substitution reactions only. Now we are going to discuss about the substitution upon the hetero atom. For this purpose, in alkylation, we are going to do with the ethyl chloride, that is alkylating agent. Alkyl halide is a reagent applied over the carbazole in the presence of dimethyl formamide. Strong base potassium hydroxide is taken as a catalyst and giving room temperature conditions over 48 hours time duration is required in order to go for an alkylation process. In ethyl carbazole is the final product. And these many examples are provided for an alkylation reaction. Let me go with the iodobenzene can be operated over the enalkylation giving rise to N-phenyl substitution. And that may be taken as a fluorinated benzene as well, so that that fluoro will replace this hydrogen giving rise to enalkylation and benzylation again. Sorry, N-phenylation again. That may being cyano is the substitution upon the benzene ring, will go with the alkaline hydrolysis giving rise to corresponding carboxylic acid. And again fluorobenzene will be treated over this carbazole and giving rise to this benzene substitution over the nitrogen. And further it will be treated with hydrazine in the presence of water, and palladium carbon is the reagent where nitro substitution which present upon the benzene ring will reduced into amine. Same compound carbazole, which is substituted with highly bulky tertiary butyl alkyl substitutions are at the suitable position and to be treated with this fluorobenzene. Paranitrofluorobenzene in specific can be operated with the catalyst cesium fluoride. Cesium fluoride is the catalyst applied over there so that enalkylation is performed upon this carbazole. And the subsequent same reduction process is applied, giving rise to transformation of nitro into amine. So this is the way all these reactions are the examples for this enalkylation only. Let me go with the enacylation process. In order to perform the enacylation process in the carbazole, let me treat with a specific acylating agent, either acid chloride or else acetic anhydride. Both the reagents are acylating agents only. And here acetyl chloride in specific treated with this carbazole in the presence of dimethyl formamide and potassium hydroxide base. Room temperature is sufficient and 48 hours stirring is required in order to go for the enacylation process, giving rise to N-acyl carbazole as the final product. And there is a provision to polymerize the substance, being it is a larger one. Again, we can polymerize in such a manner. So many polymeric substances are available in an industrial scale, so that polycarbazoles are available. Polycarbazoles are located over there, but only the difference is the linkage. Position of the linkage are only the difference. All these are said to be positional difference in the position of the polymerization, right? So these carbons with respect to this one here, 1 2 3, third position, and 4 5 sixth position, third and sixth position are participating in the ring expansion. That means a chain expansion, we can say polymerization they are participating in. 3 and 6, and here 2 and 7 taken in the polymerization process. Here 1, 8 positions are extending further, and here 3, 9 positions are taken in the polymerization process. Here is the 2, 9 carbazoles are taken for the 2, 9 positions are taken for the polymerization. These many possibilities are there for the polymerization of carbazole, giving rise to many different dimensions of the polycarbazoles, which are in turn having the conductivity in the field of organic electronic devices. So that a new era, that is OLED invention was accomplished because of such a kind of polymeric substances by means of this research exploration, right? So polymeric substances, OLEDs were introduced. Photochemical process is also possible. Carbazole will sufficiently go with the light irradiated reaction, so that let me take the carbazole with the ester functionality over the position number 2 and irradiated with the light conditions directly under solvent media, and room temperature is sufficient to operate this reaction, and this will go with the phase rearrangement. Type of rearrangement, ester will convert into a kind of hydroxy ketone. This is the kind of hydroxy ketone. There is a provision to migrate this acetyl to the position number 1 or else position number 3 as well. Both the possibilities are there because both the positions are freely available for that a migration or rearrangement process, and which in turn further used for the synthesis of carbazole alkylide moieties. This is the way photochemical reactivity is also observed for this carbazole molecule under light irradiation conditions. By this chemical reactivity segment of the carbazole successfully accomplished, now let me enter into the process called applications. Any compound which is introduced, which is synthesized, will retain its completeness by means of its applicability only. If we extend the plethora of its applicability, more will be the value for that compound. So that applications are most vital in the field of this kind of synthetic purview. So that applications of the carbazole now we are going to discuss about. Pharmaceutical materials can be synthesized starting from this carbazole. Carbazole will be this effective pharmacophore in that kind of chemicals. And we already observed about anti-cancer tumor curative agents, malignant tumors effectively curated by means of this one, which already discussed. This kind of whatever drugs which are manifested here, already we gone through them. One is called Muria folin A, and Celiptium is a kind of another anti-cancer curative, and clazinaquinone A is another anti-cancer agent. Calothrexin A, calothrexin B, both are the same derivatives. Only the distinctive factor is inoxide. Absence of inoxide is called B. Presence of inoxide is called A. And another inalkylated substance you observed, that is a keraxin, also the kind of anti-cancer curative. Let me introduce another antimicrobials. So these many antimicrobials you can notice. Here is the carbazole core. Here is the carbazole. Here is the carbazole. The extended applications are noticed for this triazole molecule. Here is the imidazole. Here is the again triazole molecule you can observe, and the chloro also located over there, which intensify this antimicrobial. Wherever chlorination, chloro or else fluoro or else imidazole or else pyrazole or else the carbazole existing within the molecule, those are effective antimicrobial agents. And these are the kind of skeletons, whatever you're observing. The motifs are selective for anti-inflammatory property, right? So celiptium is the kind of drug where carbazole in conjunction with the pyridinium acetate is a celiptium anti-neoplastic cancer curative. Caprofen is a kind of another drug which is anti-inflammatory drug. Inflammation is better curated by means of this one. And here is the another drug which is also the kind of inflammation curative one. And here is the kind of molecule with this aldehyde at the position number 2. Third position aldehyde is there, and here is the kind of 6-membered oxygenated ring system called girimibin. Antioxidant agent, it will be these many kind of pharmacological applications we observed regarding this carbazole. Let me enter into the segment called material science applications. So many material applications noticed for the kind of carbazoles. Carbazole is kind of skeleton having provision to elongate into many kinds of polymers with the different position linkages to extend the polymeric chain, so that the conductive nature is occurred for those polymeric substances of this carbazole. Polycarbazole is a kind of conducting polymer. Another exceptional property we observed here is a kind of molecule carbazole which is in conjunction with this acetylenic bond, and here is the N alkylated chain is there, here is the cyano is there. This is the kind of chain existing in this tetraannular system. Here, tetraannular system, which is having four alkyl groups at symmetric positions. All these four alkyl groups they corresponds to this kind of alkyl chain. The alkyl chain where carbazole is taken. This carbazole is responsible for this organic light emitting diode system, right? So OLED kind of system you can clearly observe. Light emitting diodes which are originated starting from organic moieties where carbazole taken as the composition of that one. This is the way material science applications demonstrated. And there is another segment. It works like a dye, coloring agent it will be. So just like indigoid dye, it able to exist the color, the kind of molecule carbazole whichever taken as a compound, as a group is in conjunction with this carbazole having the color like saffron. So this kind of dye pigment colors also manifested by means of this carbazole molecule. And we have agrochemical applications. The kind of drug which introduced having this carbazole at its skeleton will be nirosan. Nirosan is the effective pesticide in the field of agrochemicals and also insecticidal properties accorded for this carbazole moiety, right? So by this, we entirely completed the session, successfully gone through the various segments regarding this carbazole, where it is originated, and what could be the significance regarding this carbazole, how many methods are there in order to synthesize in a laboratory viable way of carbazole manufacturing, and what physical properties generally exhibited by the carbazole, and how many ways it will react with the reagents to provide a new chemical transformations giving rise to chemical properties of that carbazole, and eventually how many ways it can be applied. It will be beneficial to the society in the field of application plethora for pharmacological applications, material science applications, and agrochemical applications as well. And this session will be very much informative towards the scholars, researchers, academicians, and a kind of aspirants for the competitive exams and career-oriented preparations, those who are seriously preparing for competitive exams. In all these fields, the session will be very much helpful. The researchers, especially in the field of heterocyclic compounds, organic chemistry, natural products, and also reagent chemistry, those who are working in the material science applications, agrochemical applications, polymeric materials like conducting polymers, those who are searching for the session, what we are discussing is very much fetching towards them. And LEDs are most important nowadays. Most of the electronic devices are driven by these LEDs only, so that organic LEDs are also manufactured on industrial scale by means of carbazole, so that I feel this will be more informative towards the viewers who are watching this. And I'm hopefully you can continue such kind of enthusiasm to continue the kind of sessions. If you subscribe and share with all aspirants, so that we will go with the same extent of motivation towards new kind of sessions which are going to come in the near future in the same kind of field. Thank you very much for your patience and listening.